So we're going to continue with the paper 4 mechanics, February March 2025, question number 5 until 7. Question number 5. Three particles P, Q, and R of masses 0.6 kg, 0.4 kg, and 0.8 kg respectively are rest in a straight line. Okay, so initial speed of them is zero. On a smooth horizontal plane, the distance from P to Q is 3, and the distance from Q to R is also 3. The part P is projected directly towards Q, speed of 3. After P collide Q, P continue to move in the same direction with a speed of 1.5. Find the speed of Q after the collision. So here, there is nothing much because if you notice, the initial speed of P is 3. So we can just write here UP is equivalent to 3. And then after they reach here, they collide, and your Vp equal to 1.5. Okay, and I find the final velocity of Q after the collision. So here you can use the basic conservation of momentum, which is m1 u1 plus m2 u2 equivalent to m1 v1. Sorry, since plus m2 v2. Okay, so since the velocity of q of initial is 0, so this one you can let to be 0. So for the first one, m1 will be 0.63 equivalent to 0.6 1.5 plus 0.4 and vq. Okay, so when we solve this, so you'll get your VQ will be 2.25. Okay, it's 2.25. Okay, so the next question, in subsequent collision between Q and R, this particle coalesce. So means here after the Q collide the R, and the object coalesce. Coalesce means they stick together. Find the final speed of the particle. Okay, fine. So it's still the same conservation of momentum, but here we're going to be have something like this. So m1 u1 plus m2 u2 equivalent to m1 plus m2 v, because they stick together and move with the same velocity. So for the first case here, m1 will be your mass of q 0.4 and the speed is 2.25. So you can write here 0.4 2.25, and since here the initial velocity of r is 0, so you can just ignore this. Will be 0.4 plus 0.8 v. Therefore your v will be 0.75. Okay, now question number 5c. Find the time that take it for P initially projected at the instant P collide with the combined particle. Means okay, so let's say here is where the P is initially projected, and at this point at 3 meter, this fella collide with Q. And after that, the P continues to move in this direction, where the P move in this direction where the Q collide with R. At the instant of when Q collide with R, the P is still moving in this direction. Okay, so let's say at somewhere this point where the QR coalesce, or I let the QR equal to S. Let's assume the particle that coalesce QR R is S. Okay, so here is S. The particle or coil is at this point the P and S collide. Okay, I let the S is the particle, that is the coil is of QR. Okay, so they need to know what is the time for it to collide from here until here. Okay, so this is what they're asking for, the time, total time. So here we separate this into three different things, where the first one, we find the time for the P reached Q. Okay, the initial speed of P is 3, so the initial speed of P is just now is 3, and the distance travel is also 3. It is a constant acceleration. Since they said smooth, so we assume there is no acceleration or deceleration. Okay, so your T equivalent to 3 divided by 3, which is equivalent to 1. Okay, when Q hit R, when Q hit R, how long does the P travel? Okay, when the Q hit R, how long? Okay, so what's the duration that they travel? We find that first. So it's going to be initial speed of Q just now is 2.25, I guess. Let me check first. Yeah, 2.25. And the distance they travel is also 3 for Q. So the time is going to be 2.25 divided with, sorry, it should be 3 divided with 2.25, because your time is equivalent to distance over speed. Okay, therefore T equivalent to 4 over 3. Okay, so when the Q collide with R, okay, when Q collide with R, P travels 4 over 3 seconds. But how far? What is the distance that P traveled? Okay, so the distance that P travel is 4 over 3 multiplied with the speed of P just now is 1.5. You can use this. Multiply with 1.5. Okay, Vt. So distance equal to Vt. Therefore, you will get 3 over 2. So 2. Okay. So means the P is somewhere here. Here is 2. Here is 1. When the Q colliding with R, the P is here. Okay, I just changed my color. When the Q collide with R, the P is here. So means they travel for 2 meters. Okay. So now we find the place where the P and Q collide. Sorry, the coil is vertical. Let's say the P is here with the initial speed of 1.5, and the S, the project that coil is S just now, as I mentioned, S is here, where the distance behind here is 1 meter. And let's say here is the place that they meet. So P and S meet. Okay, so we need to find what is the duration for P to meet the S. Okay, so over here we know initial speed of P is 1.5, and then your A is 0, and for Q the speed just now is 0.75. So u here is 0.75 for QR. Okay, so we can use your SP. The SP, the distance they travel will be uh, UT. So U is 1.5 T. Okay, and since it is behind the this point, so I just put -1. Okay, and for it to distance here, so it's going to be, I can literally use S only because it's just a distance, so I don't need to put SP. And it's just for P, particle P. So for particle P. Okay, and then for S to reach here, so your S will be 0.75 T. Actually, I'm using this formula just for you to know. S equal to UT plus half AT square. Since your A equal to 0, so this part is no more already. So only have this part. Okay. So it's going to be 1.5 T minus 1 equal to 0.75 T. So we simplify this. I'll get T equal to 4 over 3. Okay, so means from here to here T equal to 1, from here to here T equal to 4 over 3, and from here to here is also T equal to 4 over 3. So total time will be, let's just now, 1 4 over 3. So 1 plus 4 over 3 plus 4 over 3. So which is going to be 11 over 3. That's it. Okay. Okay. Question number 6. A block mass of 12 kg is placed on a rough plane. So means rough plane there is a frictional force. At angle of alpha and horizontal where the arc tangent alpha equal to 0.5. So since they gave me this idea, arc tangent is this. Okay, so I'll say tangent alpha equal to 0.5 equal to 1 over 2. So we can draw the right angle triangle. Okay, so here will be alpha 1 2, so will be here is set 5. Okay, using the Pythagoras theorem, the force X applied on the block directly, the coefficient of friction is between the block is mu. Okay, it's given the mu equal to 0.15, X equal to 20. Find the time that it takes for the block to move 2 meters down. So means the direction is here. This is the direction of the ball particle. So it moves in this direction, which means this is your frictional force. Okay, your frictional force will be in this direction because the object is moving downward. Okay, for this case, right, normally I will use the direction of the slope will be the x-axis, and the perpendicular to the slope I will use as a y-axis. Okay, so since there is an x-axis already, so I just put it as another direction. Okay, so I just introduce another direction for me. Okay, so this will be my y direction, and this will be my x direction. Okay, and the thing here will be here, the weight will be mg, where here will be alpha. Okay, and then here will be your r. Okay, since the object is traveling in x direction, so your vertical will be in equilibrium. So from here you can say that your r equivalent to mg cos alpha. Okay, your r equal to mg cos alpha, which is your r. M will be 12. So 12g cos alpha 2 over sec 5, which is going to be 24g over sec 5. Okay, and then since it go move 2 meter down, means your x direction is not in equilibrium. Therefore, there is an acceleration. So we find the acceleration first. Okay, we find the acceleration. So we can use the Newton's first law, which is F equal to ma Newton's law. So the net force here is equal to this. And since the object is moving in the downwards direction, so I choose this direction as a positive direction, and the upward will be negative direction for me. Okay, so here this direction you will have mg sine alpha. Okay, so it's going to be mg sine alpha fr and x minus x minus fr equivalent to ma. Okay, so mg, so 12g sine alpha will be 1 over set 5 minus x will be 20 minus frictional force equal to mu r, where my mu equal to 0.15 and r is equivalent to 24g over sec 5 equal to ma. Okay, so we resolve this, we can press a calculator. Okay, so it will be 120 over sec 5 minus 36 over sec 5 minus 20 is equivalent to 12a. So you press a calculator, you'll get your a is equivalent to 1.4638. Usually when I use the intermediate values, like for example, now I'm going to use a to find the t. Okay, so because the question here said find the time. Okay, the question here said find the time. So I'm going to use the a to find the t. So when I want to use the intermediate values, I don't use the trace significant. Use either exact or at least 4 to 5 significant figures so that the final answer will be more accurate. Okay, so this is a constant acceleration. So we can now use Stewart formula to find the what we call time. Okay, so you can see it moved 2 meter, 2 meter, and I said downward direction is a positive direction already. So I just directly use S equal to ut plus half a t squared. Okay, so my S just now is 2 equal to u just now is 0 because its initial speed is 0. So 1 over 2, my A is 1.4638 t squared. Therefore, your t will be 1.65. Okay, for the final answer here, you can give your three significant figure, but please don't change this value. Okay, this value don't give into the three significant figure because it will be affect your further calculation. Okay, so I just recap this question again. Okay, so first the question said find the time taken to it to move. So what I know, when the object is moving downward or is moving upward, my vertical direction is always in equilibrium because it never move up and down. It never move in vertical direction. So vertical it will be equilibrium. So I resolve my vertical upward equal to downward. So I'll get my r. Okay, my r equal to this. First thing. Number two, since the object is moving in horizontal direction, so the net force is not equivalent to zero. So we're going to use the Newton's law F equal to ma in order to find the a first. Okay, because when you want to use find the time, whenever you want to find the time, okay, sorry, whenever you want to find the time, you are going to use the SWOT formula because it's a constant acceleration. So SWOT formula we use here is actually this. So I need to find the a somehow. Okay, so I use F equal to ma and resolve all the horizontal direction, and for this the downward direction I put as a positive. So for me, mg sine alpha minus x and minus alpha. Why I put downward direction as a positive is because since it is moving downwards, so I always assume the direction of motion will be positive for my case. Okay, is equal to ma. So once that you will solve your a, and just take note, please don't give this into three single figure because this is one of the most common mistake that students will do. Don't ever give your intermediate value as a three single figure. So you use either 4 or 5, or you can exact value. Okay, after that, in order to find the t, I use my SWOT formula S equal to ut plus half at square, and I substitute the t in order to find I substitute a in order to find the t. And the final answer for t, you can give the answer into three single figure, is fine. Okay, now it is given instead mu is not equal to 0.15, and then when x equal to 10, this block is on point of moving down. Okay, it is a point of moving down the plane. Find the value of mu and the value of x when, okay, means first we use this. Okay, first we use this idea to find the mu. Okay, so when they said a point of moving down, this shows that the object is in equilibrium. So we can directly use the vertical answer, my r. So my r from the previous question, where my r is equal to 12g. So I can directly take just now. What's my 24g over z5. Okay, I just directly use this. 24g over z5. I can use my r directly from what I've done just now. And also for horizontal, I can set my net force equal to 0. So it's going to be the same thing here, but I just put this side as a 0. Okay, so just use the same thing what we done here, but this one will be 0. Okay, so it's going to be mg, so 12g sine alpha is equivalent to, because it's this I can just bring out, so x equal to just now is 10 plus mu, and my r is 24g over z5. Okay, so you solve this, you'll get mu equal to 0.40683. As I mentioned, since I'm going to use the mu for the following question, okay, since I'm going to use the mu for the following question, then you must make sure that your mu is not three significant figure. Later, when you want to give the final answer, you can give it as a this doesn't matter. Okay, okay, now the question said find the value of x for which it is moving up. So when the object is moving up, then your fr, maybe I just change my pen color. Okay, when the object is moving upward, then here is your fr. So I can say it mg sine alpha plus fr minus x equal to 0, or downward force equal to upward force. So it's going to be mg sine alpha plus fr is equivalent to x. Therefore, my x equal to mg12g sine alpha plus My mu is, if you can just take the whole number if you want the whole thing, for 0.40683 multiply with r, 24 g over cert 5. So I got my x is equivalent to 97.33. So you can give a final answer. Your mu equal to 0.407 and your x equal to 97.3. Okay. Okay, now let's go to last question. Question number 7. A particle is moved in a straight line with a velocity v 6 point, given that v equal to this, where k and p are constant. This acceleration of particle t equal to 1 is 42. So it's given that, I just changed my color first, sorry. So here, the acceleration of particle at t equal to 1 is this. So when t equal to 1, a equal to 42 is already given. And the displacement of the particle from O at t equal to 1 and set s equal to 93. Show that k equal to 3 and p equal to 26. Okay, so maybe we can utilize this by using the what we call differentiate first, because they said a equal to 42. So when I differentiate, so dv over dt will be 20k plus kp minus 12. Hey, I'm sorry. Why I'm doing this? Sorry. So I explain first. 20k plus kpt minus 6kt squared. It's easy for me when I differentiate. So dv over dt will be, so this is a constant, so we can eliminate. And for this will be kp minus 12kt. So your a is equal to dv dt. So when t equal to 1, a equal to 42. So will be kp minus 12k equal to 26. Sorry, 42. Hey, what I'm doing? 42. I'm sorry. 42. Okay, and then they said displacement. For displacement, I need to integrate this. Therefore, integrate v dt will be 20 kt plus kp over 2 t square minus 6 over 3 2 kt cube. Okay, plus c, and since it start from O, so at t equal to 0, s equal to 0, therefore s equivalent to 20 kt plus kp over 2 t square plus 2 kt cube. Okay, so when t equal to 1, s equal to 93, so you can substitute here. So will be 20k plus kp over 2 plus 2k equal to 93. I'm sorry, it should be minus. Why I put plus? Minus. Minus. Therefore, 18k plus kp over 2 is equal to 93. Okay, so why is it okay? Okay, so from here, from equation number 1, I can say it kp is equal to 42 plus 12k. Okay, so I substitute here. Okay, So 18k plus 42 plus 12k over 2 equal to 93. So it will be 18k plus 21 plus 6k equal to 93. Therefore, 24k equal to 93 minus 21, 72. Therefore, my k equivalent to 3. So from here you can find your k. So 3p equal to 42 plus 12k. Therefore, p will be 6. So my final answer, k equal to 3, p equal to 6. Okay, and then B. Find the distance moved by the particle at the time acceleration is 0, and the time at which will find the distance moved by the particle between the time when acceleration is 0. So if they want to know what is the time when a equal to 0, and then the time where v equal to 0, and then we will find the distance moved within these two times. Okay, so first we can use a directly from here. So kp minus 12 kt. So for my a will be kp minus 12 kt. Okay, that's correct. Let me check first. Kp minus 12 kt. Yeah. Okay, so when a equal to 0, my k just now is 6 and p is equal to 26. 42 plus 12 times 3 divided by 3. Sorry, my p is 26. 26. So my a equal to 0. So k equivalent to 3. So 3 plus 26 minus 12k. T equal to 0. Okay. So my t will be 26 plus 2. 26 over 12. Right, because it's spring here. Yeah. Therefore, t equivalent to 1306. 1306. And for v, so v equivalent to the question here just now is 20 pt minus 6. Okay. So k 20 plus pt minus 6t square. So when v equal to 0, so I can divide with k, so it's just 0. So 20 plus 3, p is 26. I'm sorry. P is 26. T minus 6t square equal to 0. So we can rewrite as 6t square minus 26t minus 20 equal to 0. So going to factorize 6 minus 26 minus 20. So t minus 5, 3t plus 2 equal to 0. So t equivalent to 5, t equal to negative 2 over 3. So t will be 5. Okay. So since I already have the what we call the S formula, so my S just now is 20 kt So I can directly 20 kt kp. Okay, yeah, I got here also. Kpt square over 2 minus 3 kt cube. So it's 2. 6 divided by 3. Am I correct? Yeah. Okay, we substitute k and t. So k equal to where? K equal to 3, p equal to 26. So you will get 60t plus 39t square minus 6t cube. So and t equivalent to 13 over 6, my s will be 4537. 4537 over 18. And when t equivalent to 5, my s equivalent to 5 to 5. Therefore, the total distance will be 4523 over 18 plus 5 to 5. 4537 over 18 minus 5 to 5. Okay, so 5 to 5 minus 4537 over 18. So will be 4913 over 18. Okay, so you can do something like this, or let's say you are not confident, so you also can do in terms of this way. So integral from 13 over 6. So 13 over 6 to 5 b dt. You also can apply this. Okay, since I already do this in earlier here, so I already done the integration earlier, so I just utilize that over here, and then this one will be, so this will be s5 minus s13 over 6. Okay, so we can make it st. Okay, you substitute s equal to 5 minus with s equal to 13 over 6. That's it. Okay. Okay. So that's all from me. Thank you.